Okay, now we have taxi cab or grid distance. Now, I would say, taxi cab or grid distance on a grid, but you can't have them unless you're on a grid. So we'll just say taxi cab or grid distance. And again, the idea is simply that if I have a couple of points here, an A, B, and a C, D, that the distance is, now we'll see in our project that as long as I always make progress on the grid toward the point, it doesn't actually matter, did I go straight to here and then up to there, or did I sort of, take steps like this. It turns out the distance would be measured the same in both cases. I'm going to erase that. And so, as I look at this, then, in this case, this point here is, well, it's over C and up B is that point. Another way to go, I could have instead gone this way, I guess, and this point up here would be A for X and D for Y. But when I do this, what I want to think of is I'm going to take the distance from this point here over to here and add it to the regular distance from this point here up to there. Okay, so one way you could think of it is that if I find this distance, Euclidean distance D1, and this Euclidean distance D2, and I just add them, that's my taxi cab distance. So my distance here, and maybe I'll put a little T with it for taxi cab, I just want that D1 plus the D2. Well, how do I find that? Well, what I can just sort of look at it and see that, here for D1, I just want to take C minus A. But if I actually go through the whole distance thing, I could do that. But for now, I'm just going to take now C minus A, but I'm going to use absolute values, so it doesn't actually matter. I could have done A minus C. And then for D2, it's just going up here from B to D, and so that distance is D minus B. And again, I use absolute value because I want it to not matter whether I use B minus D or D minus B. And so here, this is my answer for that problem. Now that we see the answer, I'm going to actually use Euclidean distance to find D1. Okay, so D1, that Euclidean distance, I take the difference of the x's squared, so that's C minus A squared, plus the difference of the y's, B minus B squared. Now that's D1. Now I want to do D2 plus the square root, and D2, C minus C is what I have there. C minus C squared, and then plus D minus B squared. Now, what you notice is, hey, that's 0, and that's 0. And so I get the square root of C minus A squared. But that is the absolute value of C minus A. And then I get the square root of D minus B squared, but that is the absolute value of D minus B. And so that formula, you could think of it as I took the Euclidean distance to go straight across here and the Euclidean distance to go up there. And similarly, if I did it this way and that way, now in that order, I would actually get the D minus B first and then the C minus A, but it doesn't matter what order I add these things in. All right, I could do D minus B absolute value plus C minus A absolute value, so that would be fine. And, for that matter, I can switch the order inside there and say that's A minus C absolute value plus B minus D absolute value. I get the same answer every single time. So we get that, and we want to keep that order the same. Now, technically, even back on Euclidean distance, if I mix up the order inside an absolute value or a square, actually, if I mix up one compared to the other, it actually doesn't matter because they are just squares or absolute values. But you want to get in the habit of putting things in certain orders because sometimes it does matter a lot. And so you just want to get in that habit. Okay. Now, in our previous video with the Euclidean, we ended up using this point here of -3, 2, and a point here of 8, -4. And so if I want that distance, okay, distance taxicab, all I need to do is, again, take that distance plus that distance. So that's the difference in the x's, but the absolute value. So I'll take -3 minus 8 absolute value plus the absolute value of 2 minus a -4. So that's what I want. So it works really just like the Euclidean. So remember, with the Euclidean, I would have taken that thing squared, the -3 minus 8, and I would have taken the 2 minus the -4 squared, and then I would have just taken the whole square root of that. Okay, that was Euclidean distance. You could put a little E for Euclidean, I guess. We didn't do that in the first video. Okay, so that's Euclidean distance. Everything is in the same order. I just square it and then take the square root of the whole thing. So again, let's go to Desmos and see that we do, in fact, get different answers, of course. So I typed this thing in ahead of time. So the first row is the Euclidean distance. And from the last video, yes, that was 12.53. But now notice the second line, when I do the -3 minus 8 in absolute value plus the 2 minus the -4 in absolute value. Now, to get absolute value, let me do a new row. To get absolute value, I hit this A here with the absolute value signs around it, and it made one absolute value. And say I do a 1 minus 3, and then if I hit it again, I get the other absolute value. Okay, so that's how I did the absolute value. I checked that, and I get 17. And now notice that if I take those points, so I had the A was -3, 2, that one up there. The B was 8 minus 4, that one there. Whoops, I moved it. I'll go back here and fix it. There we go. And then, so what I did was I added the point -3, -4. I just took the, I moved that A value as well. So let me fix that. That should be a 2. Got to be careful when you touch stuff on the graph. Okay, so I have those points. Now I just took the x value of A and the y value of B, -3, -4, and I plotted that point. Whoops, try it again. And you see that's down there to make the triangle. And then I check the Euclidean distance from A to C. So that point there to that point there, A to C, plus the distance from C to B. And when I check that, I do indeed get 17, the grid distance or taxicab distance that I computed up here. So probably, you know, in the end, it's just going to be easiest to just type in the absolute value stuff if you use the calculator. But you could do it by adding that extra point and doing Euclidean distance and having it calculated. Now, my suggestion, just to, you know, it's a matter of practice. As I said, you know, very early on, math is hard. It takes a lot of practice, and that's a big problem. That's why a lot of people decide they don't do so well with it is, well, they just aren't willing to give it practice time. You have to practice. And so things you could do is you could try using just a bunch of different points and calculating using the absolute value, calculate the Euclidean distance, and then also calculate the taxicab distance and the Euclidean distances, say using the distance function in Desmos, and make sure you can do it. And just do it over and over, and then you should do fine on the quizzes, and you should gain confidence on these two types of distances. Okay, and I think that probably does it. Here I'm just going to go through the calculation. I get a -11 in absolute value, and I get a 6 in absolute value. Absolute value of -11 is 11, plus absolute value of 6 is 6. And so indeed, I see I get 17 for this. And, oh, and finally, again, if you write it as given, you know, 2 points, x1, y1, and x2, y2, then your distance in taxicab is just the absolute value of x1 minus x2 plus the absolute value of y1 minus y2. And again, I could have written x2 minus x1 and y2 minus y1. That would be fine. It doesn't matter which points I decide are x1 and y1 and x2 and y2. I just keep them straight, and I should keep them straight. You know, technically, yeah, if I switch the x1 and x2 in this first one, but don't switch the y1 and y2, I'll still get the correct answer. But you want to get in practice of keeping all that stuff straight. You know, keeping which point is which and keeping it in that order. Okay, so there is calculating our taxicab or grid distance from a couple of points.